going to talk about finding probabilities for a normal distribution with a table. So suppose that heights of adult men in the U.S. are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. If one adult man is randomly selected, what is the probability that he is less than 6 feet tall or less than 72 inches tall? So if we want to approach this with the standard normal table, we need to convert these values or this data value to a standard normal distribution. And to do that, we use a z-score. So remember that a z-score is the number of standard deviations that a data value is above or below the mean. And a z-score is given by this formula, x minus mu over sigma, where x is the data value, mu is the mean, and sigma is the standard deviation. And it takes any normal distribution. This is a normal distribution with mean 80 and standard deviation 5, and converts it to a standard normal distribution. So if a value is, say, 2 standard deviations above the mean, then it would be converted to a z-score of 2 in the standard normal distribution. And because normal distributions have the same shape, the probabilities corresponding to data values in the normal distribution, or areas between values in any normal distribution, will correspond to the areas in the standard normal distribution once we take the z-score of those values. So looking at, so once we find our z-score, we'll then need to use our normal distribution table or our z-score table. It's sometimes called a z-score table, sometimes called a standard normal table, and it looks kind of like this. So it will have both a negative and a positive z-score side. And so let's look back at our example. The heights of adult men in the U.S. are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. If one adult man is randomly selected, what is the probability that he's less than 6 feet tall or less than 72 inches tall? So we first need to bring this data value of 72 inches down to a standard normal distribution. And the way to do that is to take the z-score. Remember, z-score, the data value minus the mean divided by the standard deviation. So in this case, that's 72 inches is the data value we're interested in. The mean for the distribution is 69 inches. Divided by 2.8 is the standard deviation for this distribution. So when we subtract and divide, we'll get 1.07 for our standard deviation. So here is the data value. Data value of 72 inches is going to correspond to a z-score of 1.07. So there is that line. And now we know that the probability that x is less than 72 inches is equal to the probability that z is less than 1.07. And we're able to find this probability that z is less than 1.07 using the z-score chart. So we can say 1.07. Remember that the first decimal place and whatever comes before it are in the rows, and the last decimal place is in the column. So we see where these two things match up. So our second decimal place, 0.07, matches up with 1.0 here, and 0.8577 is our probability. So the probability that x is less than 72 is equal to the probability that the z-score is less than 1.07, and we found using the table that that's equal to 0.8577. So that is our probability right there. And again, the shaded purple area for probability that x is less than 72 is equal to the shaded purple area for z being less than 1.07. All right, what if we're asked for a greater than question instead? So what is the probability that he is more than 6 feet tall or more than 72 inches tall? Then we are, instead of looking at the left-hand side of that 7.2 value, we're now looking for the right-hand side. We're looking for this probability up here. So we're looking for that corresponds to this probability in the standard normal distribution. So we already know how to find this probability. We know that the probability that z is greater than 1.07 is equal to 1 minus the probability that z is less than 1.07. And so we found that above using the table. And so this is 1 minus 0.8577. So we just need to subtract, and we would have 0.1423 is that probability. All right, what if we're asked a between question? So what is the probability that a randomly selected man is between 65 and 70 inches tall? So here is 65, and here is 70, and we're looking for the probability that this randomly selected individual is in between these two values. And so we are looking for this shaded region. Well, we've done this already for standard normal distributions. So what we need to do is find the z-score that goes with 70 and find the z-score that goes with 65 and find the area shaded on the standard normal distribution. So we're going to start by finding the z-score for each of those values, the z-score for 65 and the z-score for 70. So let's find those. The z-score for 65 is 65 minus the mean is 69 divided by the standard deviation is 2.8. So the data value minus the mean divided by the standard deviation. And the z-score for 70 is the data value minus the mean divided by the standard deviation. So we can compute each of those z-scores. And we get this first z-score is negative 1.43, and the second z-score is 0.36. So we've got, here are our z-scores, negative 1.43 and positive 0.36. And so that means that the probability that x is between those two values, that 65 is less than x, which is less than 70, is equal to the probability that z is between the two values we've just calculated, that z is between negative 1.43 and 0.36. And we know how to find a probability that looks like an in-between. We find the probability that z is smaller than the large value and subtract away the probability that z is smaller than the smaller value. So we just get the part in the middle that we're interested in. And so this is the probability that z is less than 0.36 minus the probability that z is less than negative 1.43. So now we just need to find each of those using the table. So on the positive z-score side, for 0.36, here is 0.3, here is 0.06. The place where those match up is right here at 0.6406. And for negative 1.43, to find the probability that z is less than negative 1.43, we now need the negative side of the z-score table. So here's z is negative 1.4, here is 0.03. So the place where those match up is right here at 0.0764. So that means that this is equal to the first probability, 0.6406, minus the second, 0.0764, and subtracting gives us 0.5642. So 0.5642 is this shaded probability right here. This is 0.5642 is equal to this shaded probability in the middle and also this shaded probability in the middle. All right, here's an example for you to try. So IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. What is the probability of a randomly selected individual having an IQ score above 90, an IQ score between 80 and 125, and an IQ score below 125? So for each of these problems, I'd like you to also shade the corresponding probability on a normal distribution as we were doing above. All right, for the first example, an IQ score above 90. So we are looking at having, here's 90 on our normal distribution with a mean of 100 and a standard deviation of 15. And we're looking for the probability of an IQ score above 90. So we're looking for this shaded region. And we're going to say, okay, whatever z-score corresponds to that, we're going to look for that probability on the standard normal. So our first thing we want to do is find the z-score for 90. This would be the data value minus the mean divided by the standard deviation. And that would give us a negative 0.67. So the value of 90 on this original normal distribution corresponds to a z-score of negative 0.67. So there's that. So these two blue shaded areas are going to be equal probabilities. So the probability that x is above 90 is equal to the probability that we have a z-score that is above negative 0.67. And remember that anytime we're doing larger than, we are going to do 1 minus the probability that z is less than 0.67. So basically, we're finding this piece and subtracting it from 1 because the green region and the blue region together is all of the probability under the curve, which is always equal to 1. And for that, we are going to use the table. I'm not going to copy it here, but if you look up 0.67 in the table, you will get a probability of 0.2514. So this is 1 minus 0.2514. And after you do the subtraction, 0.7486 is our probability. So 0.7486 is this blue shaded region, and that's equal to the probability that x is greater than 90, and it's also equal to the probability that z is greater than negative 0.67. All right, what's the probability of an IQ score between 80 and 125? So here is 80, here is 125, and we're looking for the probability of having an IQ score in that region. So the first thing we want to do is first find our z-scores. So our z-score for 80 is the data value 80 minus the mean of 100 divided by the standard deviation of 15. And when we find that value, we'll get negative 1.33. If we do the z-score for 125, we've got the data value 125 minus the mean divided by the standard deviation. And when we calculate that, we'll get 1.67. So that 80 goes down to a negative 1.33. And the value of 125 goes down to a z-score of 1.67. And so again, these shaded areas are equal in size. So we want to find the probability that x, the IQ score, is between 80 and 125. And we know that that's equal to the probability that our z-score is between negative 1.33 less than z, which is less than 1.67. To find the area between two values in the standard normal distribution using the table, we can do the probability that z is less than 1.67 minus the probability that z is less than negative 1.33. So in other words, we are taking all of this, the probability that z is less than 1.67, and subtracting off this probability. We're subtracting away the probability that z is less than negative 1.33. And when we do that, we'll just have the blue shaded region in the middle that we want. So for this, we need the table. And again, I'm not showing a copy of the table right now, but if you look up 1.67 in the table, you'll get 0.9525. And if you look up negative 1.33 in the table, you'll get 0.0918. And so once you do that subtraction, you'll have 0.8607, and that is our probability that we are interested in. The probability that a randomly selected individual has an IQ score between 80 and 125. For the probability that we have an IQ score below 125, the probability that X is less than 125, we've already calculated that this is equal to the probability that Z is less than. We already found the Z score for 125 and found that it was 1.67. And so that corresponds to, 125 is here, less than that value is this shaded region, corresponding to a Z-score of 1.67 around there, and so that corresponds to that shaded region on the standard normal distribution. And we also already found this probability. Again, this is found using the table, looking up 1.67 as a Z-score to find a probability in the table, and that is 0.9525. And if you do draw your shaded regions, they should always sort of match up with the size of the probability that you're talking about. So this 95%, it should be about 95% of the shaded region when you've drawn your, kind of sloppy drawing. But it's clear that this blue shaded region is not like 4%. It's not like 1 minus 0.9525. It's closer to 0.9525. So can just sort of help be a little size check when you're shading these probability distributions.